Hello everyone and welcome to Azam Sharp Weekly. In this video, I'm going to show you that how you can integrate your Vapor server with the PostgreSQL database using Fluent ORM. Now the first thing we need to do is to install PostgreSQL database. So the fastest way to install Postgres is by using the Postgres app. I have already installed PostgreSQL database, but if you haven't, then make sure that you install it either using the Postgres app or using Brew. I find Postgres app to be a little bit more faster, so that's why I use that. You obviously need to also install Vapor since we will be using Vapor, and I already covered Vapor in a couple of different videos that I will link in this YouTube video in the description, so check out that. I already have installed Vapor, so we can go ahead and get started. So if you're trying to connect to the database, the first thing you obviously need is the actual database. So I'm going to go ahead and open up the Postgres app. And you can see right now that these are the different databases that I have. I have MoviesDB, PetsDB, Postgres database, Azam Sharp database, Trips database, and so on. I'm going to try to create a brand new database to store planets information. So planet like planet Earth, planet Mars, Jupiter, Neptune, and so on. Let's go ahead and click on any of these databases. It doesn't really matter. And now you will see that it brings up this terminal. And right now it actually tells you that I'm connected to the Azam Sharp database. I don't really want to use Azam Sharp database. I'm going to go ahead and create a new database. Create database, and then the name of the database, PlanetsDB, or it can be called anything you want. I'm just calling it PlanetsDB, but obviously you can call your database name anything you want. If you run this, you'll see that it says create database, which means your database has been created. Let's go ahead and say /q to quit. And now if you see over here, you will be able to see a planets database, which is right over here. This database is completely empty. Obviously, we just created it, so it doesn't really have anything. But at least we have the database. That's great. Now let's go ahead and create our Postgres application. I'm going to go ahead and launch the terminal. And from the terminal, I can go ahead and run the command vapor beta new. Now I'm using Vapor Beta because right now the release version is, or the current version is release candidate, but hopefully if you're watching this video maybe a couple of months from now, you may not have to say beta. Okay, so Vapor Beta new, and I'm just going to call it Planets app, or just Planets. Yeah, Planets app is fine. Now immediately it's going to ask it, hey, do you want to use Fluent? And actually we do. Fluent is the ORM, Object Relational Mapper, that is going to allow our Vapor app, which is in Swift, to connect and to perform object relational mapping operations like, creating, reading, updating, deleting, and all those kind of things against the PostgreSQL database that we just created. So I'm going to go ahead and say yes. And obviously, this is many different databases are supported. The Postgres is the one that I want, so number 1 is fine. And now it's basically done. Okay, let's go ahead and jump into this directory. And I might have actually created the directory at the wrong place. So I'll move the directory onto the desktop and we'll continue from there. All right, so let's go ahead and jump into the directory. There we go. And I'm just going to say open package.swift. And it's going to launch my Xcode and open the package.swift file, which contains all of my dependencies, all of the packages that I need to install. And immediately as I open, you can see on right over here, it's already trying to download all the different dependencies, which include Fluent, Fluent Postgres driver, Vapor, and so on. We're going to let it download all the dependencies. Once the dependencies have been downloaded, you will see that right on this section, the target will be set up and the scheme will automatically be set up. But first, let it download all the dependencies. It is going to take a little bit of time to download these dependencies since it's downloading it for the first time. But after that, it will be it will be instantly. All right, so let's just wait for that to download. And once it's downloaded, we'll continue from there. All right, so our dependencies have been downloaded. Make sure that you are selecting the correct target and make sure that you are selecting Mac and not your iPhone, because we are going to be running Vapor Server on the Mac and not on your iPhone. Okay, so the first thing we should do is to definitely configure our database. So we'll go to the configure.swift file, and you can see that all of this code is already added for you, which is to use a Postgres database and all that stuff. I'm going to remove that and write it again. All right. So app.databases, and this is basically where we will provide our database is Postgres. So just go ahead and say Postgres. We also need to say host name. So I'm just going to say host name. So host name basically is that the server on which the database will be running. And in this case, the database is running on the local computer, in other words, localhost. Username, well, whenever you use the Postgres app, it automatically creates a Postgres user with the username Postgres. So we're just going to use that. And that Postgres user has a password, which is nothing. Now, obviously, you shouldn't be using that for your production. You should create a new user with a new password and a role and everything. But to keep things simple, we're just going to use the default one. And obviously, the most important thing is the database. What is the name of the database? So I believe our database is called PlanetsDB. We can always go ahead into Postgres and double check the database name, which is PlanetsDB. Okay, so that's all good. And we are going to say that we will be using PSQL, meaning PostgreSQL. And this ends the configuration part at least. Let's go ahead and build our app. Now, after configuration, what we need to do is we need to create models in our Vapor app, because our models will be equivalent to a table in the database. And the properties of the model will be equal to the columns in a database table. That's how ORM works. So if you are still not sure about ORM, I would suggest Google ORM and read more about object relational mapping. This is very, very common. These tools are available in .NET environment, obviously Ruby on Rails and Java, and it's just going on for a very long time. So these are not some new ORMs or new tools. ORM technology had been around for very, very, very long time. Okay, so I'm going to jump into models. You can see that we already have a model called to-do. And the reason we already have this model is that because we use help from Vapor when we said, yeah, we want to use Fluent. So that's why it created this model for us. I will not really be using this model. I will be creating my own model for a planet. So I'm going to go ahead and add a new file. And I will call this planet. Let's go ahead and import a couple of different things. The first thing we need to import is Fluent. And we also need to import Vapor. And now we're going to go ahead and start creating our class, which will be called planet. It will be using model and it will be using content. So what is model? Model is a built-in class. And if you go and jump into that class, you'll see that this class is already in the Fluent. And it provides you with a couple of different things. It provides you with different functions that you can query, provides you like a save operations and all those things that you can do with your planet model. So in order to create a model which will represent the actual table in the database, you should make sure that it is conforming to model. We're using content over here because we want the planet class to be encodable and decodable, because eventually we will be sending JSON as a planet and we will be getting back a list of planets. All right. The next property that we need to set is schema. Schema basically simply means that what would you like your table to be called? So we're simply going to say, not movies, planets. There we go. So Common convention is that the name of your actual class obviously should be singular, and the name of the table should be plural, planets. Now, one of the things that we require in our planets table is a primary key. So we are going to use an incrementing ID key dot ID. Now, I'm calling it incrementing. It's not really incrementing kind of ID. I mean, I can show it to you that if we go to the movies DB, which is an existing database, not like that, if we use PostgreSQL or some other tool, so let's go ahead and show it to you. And if you open up this, you can see that this is the ID column right over here. So it's unique key, like a GUID ID, GUID. It is basically to show the uniqueness. So it's a primary key, it's a column which stores the primary key. Var, and now the name of the planet. This is your custom stuff that you want to save in the database. And in the table, we will create, or we will refer, which will be simply calling the name. So the property in the actual model is called name, and the key is also called name, which is the column in the database table. Now let's go ahead and create some initializers. So first one will be empty, and the second one would take in the ID, UUID. By default, we will just assign it nil, and not title, but name, which will be string, and self.id equals to ID, self.name equals to name. Pretty simple, all right? Now this is great, and this is our model, that's fine, but what we need to do is we somehow need to end up with creating the planets table. We don't really have a planets table. If you go to your planets DB database, which is right here, and I'm using PostgreSQL, but you can use any other tool to look into the database in a more graphical format. So let's go to the planets DB, and you'll see that we don't really have any tables. And if we don't have any tables, we can't really store any information about the planets because we don't have any tables. So we need to create the tables. Now it will be very tempting to use the table feature over here to just add a table. But since we are using an ORM, Object Relational Mapper, Fluent, it's a much better idea to create the tables using something called a migration. A migration is simply kind of like the history of the structure of the table. So we're going to go ahead and add a migration that will allow us to add a particular table. So anytime you are doing anything with changing the structure of the table, like adding a table, removing a table, updating a table, changing the column from string to int or int to float or float to int, and any kind of change, or renaming a column, you should use a migration, because you will have a history, and a new person that joins your team, they can simply run the migration to get to a particular state. So I'm going to go ahead and add a new file over here, and you can name this file anything you want. I'm just going to call it create planet, all right, because this is used to create the planet table. Let's go ahead and import Fluent. We will also import Fluent Postgres driver, and we will go ahead and create a structure which we will call create planet, which will be conforming to the migration protocol. Now, whenever you're using the migration or trying to conform to the migration protocol, you need to implement two different functions. The first one is the prepare function, and the other one is the revert function. The prepare function basically means that this is what you're trying to do in this migration. We are trying to add a column, we're trying to remove a column, or these kind of things. Whatever you do in the prepare function, in the revert you always do the opposite. So this, you can think of the revert as the undo function. So maybe you made a mistake and you want to undo. Well, then you type it over here. So what do we want to do in the prepare function? Well, we want to create the planets table. So database.schema, and we will call our table planets because plural. That table will have an ID column. That table will have a field, meaning our own custom column, which will be name, and it will be of type string. And that's pretty much it. Let's go ahead and create it. So in the prepare function, we are creating the planets table with the ID column and a field called name, which is string. So what should we be doing in the revert? Inverse of this, which means we should be deleting the whole table. So database.schema, movies, not movies, I keep on typing movies, planets, that's the table name, dot delete. Simply deleting the table. Whatever we did over here, we're doing the inverse over here. Okay, that's good. Just because we have created a migration does not really mean that it's going to just execute on its own. We have to configure it. So let's go, and in the configure, you can see that we already have one migration, which was already added for us, which is the create to do migration. So I'm not going to use that. I'm going to add my own migration. So app.migrations.add, and the migration that we are adding is to create a planet. That's a migration we just added. Let's go ahead and build it. The other thing that I want to do is I want to make sure that my folder is set for working directory. So I'm going to go ahead over here and use custom working directory and set the current folder, which is on desktop, which is planets app. So that the current directory is the actual, so this is the runnable directory. So this, we can create some different folders if we want and serve some public stuff like images and all that, which we will not be doing, but it's a good idea to do that. Okay, now in order to create the table, we have to run the migration. And in order to run the migration, we will have to go back to our terminal. Let's go ahead and say clear. And in order to run the migration, we should be inside the current app folder, which we are, planets app. I'm going to go ahead and say vapor beta run migrate. Now obviously when vapor will be released and everything, you don't have to type vapor beta, you'll simply say vapor and it will just work. Now this is going to build your application, and then it's going to also try to run the migration. This is a very long process. It is going to take some time. So we will come back once the migration has been completed. All right, so it took a while, but we are right at the end, and it's saying that would you like to continue? I'm going to say, because I do want to run the migration, and it says migration is successful. I'm not really sure what these errors are. I think the last time I ran, I was not really getting these errors, so maybe the Vapor version has been a little bit updated or something, but these are warnings that are coming up. Okay, now if the migration ran successfully, we should be able to see the table in our PlanetsDB. Let's go ahead and refresh it, and we see a table right here, planets. Let's open this table up. Well, great. Okay, so this table has an ID column right here and a name column right here. It doesn't really have any data because we just created this table. You will also see that there is another table that got created, which is called the Fluent migrations. This table is maintained by Fluent, and it is used to keep track of which migration have already been run. So it's not going to run it again, unless of course you undo the migration. Don't mess around with this table. This is only for Fluent to keep track of the history of which migrations have been run. So we have our planets table. The question is, well, how do we insert a particular planet or a particular item to our database? Let's go back to our routes. We have a couple of routes over here already added. These are all default routes. I'm going to just remove all these routes. And let's go ahead and add a route, app.post planets. All right. And we are going to get the request We are returning something, so I'm just going to say event loop future, meaning we're going to return a future. So it's not going to return immediately, but it's going to return, well, it's going to return immediately, but then it's going to take some time to return the actual promise, which in this case is a event loop future of a planet in. And now we can do something to actually save our planet. Request.content, keeping in mind that when the person is sending a request, it's a JSON request, and they are sending in the body of the planet. We'll take a look at that. Content.decode, and then we will decode the body which is coming in as a post to be saying that this is a planet.self, meaning the planet type. Try, because this can blow up, and this will eventually give us a particular planet. So the content over here in the request is actually the body, and the body which we'll be sending as JSON, it can be anything, but it has to be something that will map correctly to the planet class. So we will not be sending the ID because we're trying to create a planet, and at that time we don't have the ID. The ID is only generated when you actually successfully save the planet to the database. So the only thing that we need to send is the name of the planet, and that's it. Let's go back again to our routes. Now we can go ahead and say return planet.create, which is a function. Create is a function that we automatically get because our planet class is inheriting from the model. So we're automatically getting all of those cool things. So create means it's going to create. The database is already in the request, so request.db. .map, after you create it, we're simply going to return that particular planet. And that's it. All right. Now we do need to find a way to invoke this particular route. And I believe this particular route will be something at localhost 8080/planets, and it will be HTTP post. The quickest way to check if this route is working is to use a networking tool like Postman. So let's go ahead and run Postman to see if this is even working or not. All right, so what I'm going to do is, first of all, I'm going to go ahead and run my server, because if I don't run my server, obviously I'm never going to interact or make a post to this particular route that we have. Also make sure that your database server is running, which means your Postgres is running. So if I go over here, I can actually go and open Postgres, and I can see that the Postgres is running. This is your database server. Okay, so we're running at localhost 8080, and we have to send a request to planets. So let's go to over here to Postman. We'll say post, and I'm going to go ahead and say 8080, and we will go to planets. The headers we need to set so that we can tell that the request is of a particular content type, which in this case is application JSON. And we also have to set the body raw, and this is where we will be sending an actual JSON. So it has to be valid JSON. The only thing we need to send is the name itself, because there is a name property in our planet model, and we can send in any value that we want. This is valid JSON. That's why this is wrapped up in quotes. Now, if I don't wrap it up in quotes, you will see this error. This means that this is not valid JSON. If we perform this request, and if it is successful, we should be able to get the same exact planet, which in this case is Earth, planet Earth, but with an ID column also. So if I go ahead and send it, you can see that I get the same exact object back, but I'm also getting the ID. Why is that? Well, if you see over here, once we get to the post, we get the planet, and then we create it, and then we return the new and updated planet, which in this case contains the ID, because now the item or the planet has been saved to the database. If we go to the database and refresh it, there we go. We can actually see the planet which has the ID and which has a name. I can go ahead and save another planet also if I want to. Send it, and I'll get back a different ID, a unique ID for Mars. And I can go ahead and refresh our database to see that the Mars is also saved. So in other words, we have created our Vapor server in Swift, which is completely integrated with the PostgreSQL database, and we can interact with it by sending the correct request and the data. So this is really amazing, and everything over here you can see that we had to write completely in your favorite language, Swift, to create the server. Now, once you have this, obviously you can create the client in iOS SwiftUI or UIKit and you can interact with it. But this will give you at least some sort of a start that, hey, I can create my whole server in Swift language. So I think this is very, very cool. Now, this is obviously the tip of the iceberg. I mean, there is so many different things that you can do with Vapor. And that's why I have a brand new course, which is Server-Side Swift using Vapor in iOS. Now, this course is going to teach you everything you need to know about Vapor and how to create amazing Vapor app integrated with PostgreSQL. You can see we have a whole section on PostgreSQL integration, which performs create, read, update, delete, basically the CRUD operations. We also dive into one-to-many relationships, many-to-many relationships, leaf template for creating server-side pages. And the great part of this course is that I will show you how to integrate a Vapor server with an iOS SwiftUI application. So we are going to be building a complete application, a movies app, which will allow you to see that, okay, now I have created the server, but how do I integrate it with my SwiftUI? So that course is going to cover everything you want. The best way to get this course is to check out the link in the description. Please use the link in the description of the YouTube video. That will really help me a lot. And there are many other courses in the YouTube description. So if you like some other course, definitely go ahead and check it out. Thank you so much for your continued support. And if you like this video, go ahead and give me a thumbs up or click the like button and tell your friends also about the channel. I'm working very hard to make this channel as best as I can. So the more people visit this channel, definitely it will give me idea of like more updates and more videos should be added. All right. Thank you so much. Check out the YouTube description for the links of all my courses. And I really hope that you enjoyed this video.